Okay, 17. Here we go. Y prime. There you go. This is nice to give us y prime. And, let's go with green. Equals 6 times x plus 1 times x. Ooh, minus 2. Um, there we go. Squared. Okay, and they must find local max, local mins, and points of inflection. Okay, well, it's nice enough. Z equals 0. We find the critical points, so negative 1 or 2, negative 1 and 2. And so we get y prime. To the left of negative 1, big negative number, that's negative. Notice x minus 2 squared will always be positive. So this is less than 0. So it's decreasing. Between negative 1 and 2 it's 0. Positive, positive, increasing, and bigger than 2. Positive, positive, increasing. So this looks like it is a local minimum at x equals negative 1. And here, it's increasing and increasing, so it's going to increase, level off, and increase. So we got a horizontal tangent there, like x cubed. Now notice here, we don't have the equation for y, so I can't tell you what the local maximum is. I just know it's at x equal negative 1. All right, inflection points. Inflection points happen, and the second derivative is 0, and it changes concavity. So let's take the second derivative. I am going to hold the constant out and do the product rule of the inside. So I got first times the derivative of the second plus times the chain rule times 1 plus the second times the derivative of the first. So that becomes 6 times. Let's see. Do I want to multiply all this out? And the answer is, let me erase this and let's think about this. What am I going to be doing with this? I'm going to actually want to set this equal to 0. And I can divide the 6 out. Let's make this easy. So that's gone. And if I could factor this, that would be the best, because then if I factor it, I get two things multiplied together equaling 0, and that's an easy thing to work with. So let's factor out x minus 2. And then that gives me a 2 times x plus 1 plus an x minus 2 equals 0. So x minus 2 times 2x plus 2 plus x minus 2. So I've got a x minus 2 times 3x equals 0. So x equals 2 or x equals 0. Okay, so let's do the same type of thing. 0, 2, and we'll look at y double prime. A negative number, big negative number, well, that's going to be a negative times a negative is a positive. Between 0 and 2 is a 1, so that's going to be a negative and a positive. So this is positive is concave up. I think I just said one thing maybe or another, I'm not sure. At 1, this is negative and positive, so that's going to be a negative, sorry, concave down, and greater than 2, positive, positive, concave up. Okay. And so I've got changes concavity at 0 and at 2, so x equals 0, x equal 2 are inflection points. All right, got it? Good.